tsunami, which could be only a few centimeters, it is also trigger the algorithm detection. So I think for me, it also could trigger the detection algorithm, and it could be very risky to be warned automatically to the people. And my second question is for Pak Januar. I think Professor Ripepe also mentioned about the threshold that you of the STA and LTA ratio that is implemented in the detection algorithm in Stromboli volcano using the elastic beacon. So my question for Pak Januar is, what is the threshold of the STA LTA ratio in your algorithm detection, and what kind of what is the period that you use for this algorithm? Thank you.
Yeah, Suchi, thanks for this question, because this is a quite important point that we have discussed many times with Italian civil protection. Because from one side, we did a very sensitive, we developed very sensitive algorithm that allows us to detect the tsunami before we know actually which will be the maximum amplitude. And this is open a lot of discussion because because as you said, probably to provide an alert for a small tsunami, it's generating confusion on the population.
Chaos.
Chaos, and you are perfectly right. But in the case of Stromboli, during summertime, we have 5,000 people. And we have only 3 minutes to warn them. So we cannot think how big will be that tsunami. We have no time to look at how big will be the tsunami. Because one of the main aim of a tsunami early warning is to save life. And even if you are able to save one life, it will be worth to give an alert. So the general idea that we are following for Stromboli is to provide an alert anyway for Stromboli, okay? Anyway, it doesn't matter how big the tsunami will be. But then to wait until we know, okay, the tsunami is fully developed, and then we will know the amplitude of the tsunami, and then we send an alert to the Italian coast and to the other islands according to the height and amplitude of the tsunami. So this is the general strategy that we are going to follow for Stromboli, to warn Stromboli Islands, Stromboli coast, as soon as we can, because we have no time for thinking and for understanding how dangerous the tsunami will be. Absolutely no time. But then to wait until, as I said, until the buoy is recording the tsunami to understand how large the amplitude of the tsunami wave is, and according to the modeling, to deliver an alert also to the other islands and eventually to the Italian coast. So this is the strategy that we are following. I don't know if I was clear enough, Suchi.
Yes, it's very clear. If I can continue my question, do you also provide the updated warning when you have updated analysis of detection?
Oh yes. Yes, this is something that it's in progress. It's in progress, of course. I just remind you that we were running this system for 11 years without tsunami. And in the last 2 years, we are recording tens of tsunami. So, so you face the problem. I mean, you tend to solve the problem as soon as the problem is appearing. So this is something that is in progress. It's something that cannot be solved only in terms of tsunami early warning system. We need also to do a lot of modeling and to understand exactly which is the maximum height, because this is something that we cannot import from earthquake or tectonic tsunami. So the period of volcano tsunami, it's very short. This means that you can have a tsunami of 2 meters high at the source, almost with no effect on the coast, okay? Because what makes the difference is the period. And in this sense, also, we have to reconvert all the systems that we use to monitor tsunami, tectonic tsunami, because as it was presented before, for example, sample rate, it's still very, very low or high. So I was seeing in the previous presentation, sample rate, the minimum it's 5 seconds, but it's up to 2 minutes. So, and 1 minute, it's more or less the period of the tsunami. So this means that we are risking to lose to detect a volcanic tsunami if we keep this sampling rate. Okay, so a period, it makes the difference. And there is a lot of effort to understand exactly which is the minimum height or the maximum, the minimum height or the maximum height below which there are no effects. Okay, and this is a matter of models. Suchi,
Yes, thank you very much.
Thank you very much, Ibu Suci, for the question, and Professor Ipepe for the amazing answer. Let's move on to the second question from, maybe we can move on first from Dr. Annunziata. Is there something you want to say?
Can you hear me?
I can hear you very clearly.
Okay. Now I wanted to, 1 second. I wanted to distinguish a little bit between the treatment that is done with using the beacon of Maurizio and the tide gauges. Those are very different instruments, because in the case of Maurizio Di Pepe system, he's using this deep water signal, which is filtered and then filtered out numerically, which gives a very, very clean signal, so that this number 20 in the STA LTA ratio can be achieved. But if you try with normal tide gauges, and in my, let's say, sea level machine, you can see always the STA LTA calculation. You will see that with 20, you would need a very, very high threshold to detect the tsunami, because the noise that you get in the LTA is much larger than in the case of the beacons, which means that even if you have, for example, 1 centimeter, if you have 1 centimeter of noise, which is very, very low for this type of instrument, normally you have much more than 1 centimeter. If you would have 20, it means that you need to have 20 centimeters. Or if you have 5 centimeters, it means that you have to have much larger tsunami in order to be activated. So probably this should be taken into account when you want to apply the same method to the various devices, and you have to take into account the difference between the various systems. Thank you.
Yes.
Thank you very much.
Thanks for this clarification. I fully agree with you. I mean, it's this is what we see also when we compare because also at Stromboli we have tide gauges which are along the coast, and the noise is much larger. So some of those tsunami, for example, the last tsunami that was recorded at the buoy was 1.5 meters, was not visible on the tide gauge at a few kilometers away from the elastic beacons. And so the extra, the extra factors for having a sensor which is at below the sea level, the sea water, is that you filter out naturally all the noise of the surface of the water. So actually, as I said, we apply an extra filters, but just because we want to have the signal as clean as we can. But it will be even the system will be even robust without filtering numerically. So I agree with you, Alessandro. So STA LTA probably is not effective when you use tide gauges.
Thank you very much for the clarification from Dr. Annunziato and also Professor Ipepe. I'm sure that we all agree on the terms that mentioned. And I'm going to just move on to Madam Suchi's question to Pak Januar. Pak Januar, can you hear me?
Okay, I'll try to answer.
Yes, please.
That is a very good question from Bu Suci. Then I think Pak Alessandro and Professor Maurizio already describe or explain about the characteristic of and the problem faced if we use the STLT problem, especially for high noise. And as we know, STLTA is very unique. It cannot be set up generally for all sensor. We have for the one side to another side is very unique. So we have to try and error to set up the parameter of the STLTA, and we need more experience or historical data from the tsunami happened in the past to make this method work well. And but we also the STLTA have a problem about the high noise in the surface wave. So we can only detect for the significant wave only, not for tsunami less than maybe 10 centimeter. I think that's all my answer. And in the future, we hope we can learn further more detail to Pak Alessandro and Professor Maurizio how to enhance our TDA detection using STLTA. Thank you.
Is there any addition about Pak Januar's statement about enhancing the STA-LTA? Dr. Annunziato and Professor Ipepe, is there any addition to what Pak Januar has already said?
No, let's say it's perfectly valid what he said. Of course, if let's say a general data collection from all the devices like BMKG is trying to do. Of course, very careful. You need a very careful analysis of each of those. So it's good to establish methods that allows you to calibrate the data based on current data, but also on the basis of previous data in order to identify the correct parameters for the system. So I fully agree, and I am available to collaborate with you.
Thank you very much. We are very hopeful about your collaboration together, and hopefully that will be beneficial for both Italy and Indonesia. Thank you very much. I believe we're gonna move on to the next question that will be asked by Bang Musa.
Thank you, Hafiz. Can you hear my voice?
Your voice is perfectly clear. You can
Okay,
ask the
thank you.
question.
Yes. Thank you very much to Professor Pepe, Dr. Anunciato, Papa Semedi, and Pak Janwar for delivering the excellent presentation. So we can get many insight from your presentations. My question maybe for Professor Pepe and Dr. Anunciato. As we are know that Indonesia, according to the official information series of tectonic tsunami confirmation on the offshore, we use instrument buoy and tide or tsunami gauge on the coastline. Then, as we know that before 1900, 19,000, we have several non-tectonic tsunami in East Indonesia, such as from North Sulawesi, we have Ibu Mount and Banua Wuhu Mount, and Maluka, we have Teon Mount, and so on. So we have many volcanic or seamount in the East Indonesia. If I saw your presentation regarding the Sunda Strait, we can make the observation equipment in the inlets near or close to the Anak Krakatau Mountain. So how if we dealing with the early observation regarding of the sea level observation earlier from those mountains in the East Indonesia, because they are also this village that tsunami prone area or human settlements near to the mountain. Yeah, that's my first question. And the second question is, is there any non-tectonic tsunami event in the past, especially in Italy, which successfully practiced early warning to reach the community timely to save lives? Not only in Italy, maybe in the other country that we can also learn, maybe also in the very long time ago. Okay, please tell us the story. Thank you.
Which one are you going to hear from first, Bang Musa? Is it Professor Pepe or Dr. Anunciato?
Okay, maybe Dr. Anunciato.
Okay, from Dr. Anunciato first.
Yeah.
Please, Doctor. You're still muted. Can you unmute first, Doctor?
Can you hear now? Yes.
Yeah, I can hear you perfectly.
I think that the main problem is to identify the location where to install and where also you can have a sufficient connection. And you have seen that in the case of Krakatau, it was quite complicated, and it took quite some time in order to have the sufficient communication power. Once you have identified that, then you can install any type of instrument, and then you can monitor and then process the instrument data. Of course, the case of beacon is different. Maybe Maurizio can reply, because that you can install very close to the volcano, but then you must have data connection there. And again, the problem again is strictly related to the availability of connection, sufficient connection. You can use also satellite communication as it is done from the buoys, but normally this requires quite strong power. We have seen in the case of Rakata Island how big should be the solar panels in order to provide sufficient power to the and to allow the satellite communication, and also the cost probably is much higher. So I think all those elements should be taken into account, and every single volcano has its own particularity and need to be analyzed.
Okay, thank you, Dr. Annunziato.
Thank you very much, Dr. Annunziato. I think it's best that we can hear from Professor Pepe as well. Thank you very much, Dr. Annunziato, for the brief explanation.
Well, the only experience we have right now, it's a Stromboli in the Mediterranean area. So, and what Alessandro said, it's correct. I mean, the main problem is connecting the instruments with the monitoring center. But I think this is valid not only for tsunami, it's valid for every monitoring, every instrument. So seismic stations needs data connections. So if you have a volcano, I guess you should have a volcano observatory, so you can radio transmit the data to volcano observatory. So the other point is for me, I stress it, it's sampling rate. Sorry if I go back to sampling rate, but sampling rate has to be fast. So not as fast as a seismic station, but at least as fast as 1 second. If you don't sample at 1 second, then you risk to miss the signal. So, so sampling rate. And the other point for me, this is what we learned at Stromboli, is that we cannot have the instrument on the coast, because if you record the tsunami on the coast, it's too late. Those are the things that we learn just at Stromboli. So even, for example, when we start at Stromboli, we had no 4G coverage on the side of the Sciara del Fuoco. That's why we radio transmit on land by using normal radio transmissions, and then to the monitoring center. And this is quite effective because it has been used for years for seismic stations, for GPS, for tilt meters. So the second point, it's sampling rate, because otherwise, if you don't have a high sampling rate, there is no way to reduce or to increase the signal to noise ratio. And I forgot the third point. Yes, not to have it along the coast. This was one of mandate of the Italian civil defense to us. Okay? Because of course, the easiest solution is we put it on the coast and it's solved. But the mandate of Italian civil defense was not to have it along the coast, not to have it attached to a small island, because it will be too late. So at the beginning, Italian civil defense was only considering the risk at Stromboli. Now, after years, they understood that there is also risk for the Italian coast, but at the beginning, was only for Stromboli, so not on the coast. And this is why we came out with this solution of having outside on the open sea and in front of the volcano. So this is the experience that we have. And as far as I know, there are no other experience in terms of delivering alert for volcano tsunami in the Mediterranean area.
Thank you, Professor Pepe, for your answer.
Thank you very much, Professor Pepe, for the brief answer, and I hope that I think that there was very good explanation for Bang Musa. And there's also another question from Bapak Denny from Pandeglang. He will ask the question in Indonesia first. He will ask the question to Pak Januar and Pak Semedi. Boleh Pak Denny? Boleh ditanya Pak pertanyaannya? Mohon izin Pak. Pak Denny is from BPBD, so the Disaster Reduction Organization of Indonesia from Pandeglang. Halo, Pak Denny, can you hear me? Bisa dengar Pak? Halo? Maybe I will just. Halo Pak Denny, bisa coba Pak ditanya pertanyaannya? Halo? Okay, maybe I will just ask the question to Pak Januar and Pak Semedi. The question is, bagaimana dengan peringatan dini tsunami yang diakibatkan oleh Gunung Anak Krakatau? Selain satu-satunya memantau keaktifan gunung tersebut, apalagi selain memantau gunung tersebut, karena kejadian 2018 tanpa ada tanda-tandanya. I will just try to translate it to English, maybe. How do we respond to the early warning system of tsunami caused by the Anak Krakatau volcano? Because one of the activity of the volcano need to be monitored. What can we do beside on the monitoring that we've already done? Because the 2018 event had gone without any major signs, that he claimed that we had no major signs, and then it eventually just happened. Gimana tuh Pak? Maksudnya belum ada tanda-tanda yang jelas, tiba-tiba langsung muncul gitu. Terima kasih. Pak Januar, can you please answer first, and then maybe we can hear from Pak Semedi.
Mungkin mohon izin, mungkin lebih pas ini kalau bicara Krakatau Pak Semedi, karena secara konsep bagaimanapun beliau, saya banyak belajar dari beliau. Monggo Pak Semedi.
Okay. Pak Semedi, can you please answer the question?
Yes, thank you very much. From the technical points of view, yes, I can answer. So the most important is what we can do is to ensure the technical capabilities, of the system, as mentioned many times, for example, by Professor Pepe, about the quality of the data. For example, it requested every 1 second. So far with the satellite telecommunication, ADSL can deliver data even below a second. So please, Alessandro, confirm this one. I think it's about 0.7 second, and then the latency time, as already presented, it's below 10 seconds. More than 90% of the data is below 10 seconds. And the alert, and the alert is also working. So the problem now, this is all these data sent to the server of BMKG, and then as far as I understood, that in BMKG, the INA TNT, they don't have a direct automatic system to the INA TWS. Please confirm this, Pak Januar, if they can immediately or automatically receive all the warning or the alerts, for example, and then included into INA TWS. This is something we don't know, and I think maybe Pak Januar can explain about this one. In case we have alert, for example, from ADSL into INA TNT, how this is going to be integrated into INA TWS, Pak Januar? Maybe you can answer this one.
Thank you, Pak Sumedi. Our procedure in BMKG, of course, everything alert from the sensor must be verified by operator. Not only from the sea level aspect, we also consider from many parameters such as seismics, maybe if any HF radar, from any parameter what can we get at the moment. The operator is the key, because we have also procedure, and from Inatenti we also has a GUI that can send what we call service level 1 for the tsunami alert product. So if the operator can confirm and verify that's the actual tsunami, so we can directly issue the warning. I think that's all from my side. Thank you.
Thank you, Pak Januar. I would like to ask Mauricio also. Mauricio, this is very interesting, because in our case we still need human, to deliver the alert. But you said in your presentation, you told us that it's all automatic for the case of Stromboli. Maybe you can explain more on this one. Yeah.
Yes, I was just going to say a few words about this point.
Yeah.
First of all, because as far as I know, I don't know which is situation in Indonesia, but the general procedure, if we apply general procedure that we use for tectonic tsunami, is that we need at least 10 minutes to verify that the source is generating a tsunami, and the tsunami, that the source is able to generate a tsunami. This is 10 minutes, it's the normal time that we need to understand if an earthquake is able to generate a tsunami. So if we apply the same time to a volcano, clearly we are failing. So it's 10 minutes is too long. We cannot wait 10 minutes. Okay, and this is why we moved into an automatic system. Of course, we are dealing with volcanoes, and volcanoes are not earthquakes. Earthquakes, they do not give us the time to understand the network is going to occur before it's really occurring. But a volcano, we have at least 1 or 2 minutes, okay? At least 1 or 2 minutes. This is our experience on Stromboli, because there are 2 ways. Essentially, you need to have a flank collapse, or you need to have a strong pyroclastic flows or debris avalanche. And if you have a volcano, which has, of course, is monitored, probably you can use a couple of instruments to understand that something is going on the volcano. For example, you can use acoustic pressure, as Januar was showing, not only for meteor tsunami, but also for large explosions. So you can detect the explosions before the tsunami is formed. You can use ground deformation, because if the flank is going to get unstable, this will deform the volcano. So you can use ground deformation sensors to understand that something big is going to occur. And don't forget seismic waves. Seismic waves are always working. Doesn't matter if the flank is unstable above or below the sea surface, is going to generate seismic waves. So from a volcano monitoring point of view, you have at least 3 ways to understand that something is going on a volcano. Acoustic waves, if you have a big explosions, ground deformations, and seismic waves if you have a flank collapse. So this could give you a pre-warning. I'm not saying that you can already deliver a tsunami warning, but you can have a pre-warning, okay? And then you have probably 1 or 2 minutes. You have no more before the tsunami is generated. And at this point, you have to take a decision. You want to wait until you observe really the tsunami on the coast, or you want to deliver an alert before it reaches to the coast. So this is what we have been discussing for long years, for many years in Italy. So the decision was to go through automatically, completely automatically. So, and you have to trust. I mean, it's risky. It's a lot of risky. As Suchi was pointing out, we risk to give an alert for a very small tsunami. Okay, but as I said before, which is the cost of one life. So this is something that we have to take in consideration. So we do this to save lives, and automatically seems to be at the moment the only solution for volcano tsunami. I don't know if I answered to your question, but probably there is more to discuss about it.
Yeah. But in your case, you have population in Stromboli, right? Very near, or at least,
Yes, we have a we have only 200 people during normal time, but this becomes a very crowded place in summertime, up to
weekend,
5,000, 6,000 people. But
Right.
the closest island is only 10 miles. So the tsunami will need 7 minutes to reach other islands, and only 15 minutes to reach the Italian coast. So if we use a standard procedure of an operator that is confirming the tsunami, it will be too late.
Right. Yes. Thank you, Maurizio.
But in fact, if I may add something, all
Yes,
depends on,
please.
yeah, all depends on the distance between the populated places and the volcano. Because in the case of Krakatau, for example, if we take the closest populated place is Sebesi Island, and this is about 15 or 20 minutes, if I'm not wrong. So this means that we have more time. In the case of Stromboli, of course, people is exactly on the volcano, so probably the requirements are different and should be analyzed on a case-by-case basis.
Yeah, agree.
Thank you very much. Is there any more response to what already been said by Professor Pepe and Dr. Annunziato, Pak Semedi?
No, thank you very much. But I fully agree with the opinion from Professor Pepe and also from Alessandro. So this is really case by case, yeah. For the case of Indonesia, also I think we have volcano with population, and then this means that the treatment of tsunami warning system should be different. It really depends on the situation. It depends on the conditions of the threat itself, yeah. So we cannot generate, like for example now, we have a functional, operational, excellent one with INA-TWS based on the earthquake sensor. But for the atypical tsunamis, non-tectonic tsunamis, this is definitely our homework. So we need to do lots of work to identify, because Krakatau difference with other locations, yeah.
Yeah. Thank you very much. We are obviously rooting for you guys to make some advancements to the INA-TNT and whatnot, because Italy and Indonesia need you guys this knowledge, I believe that, and I'm very glad to hear that from you. And is there any more questions? I'm checking first. There are no more questions. I believe that Madam Suci will say a few words. Okay, no more. I think that's all. Oh, Pak Daryono want to say something?
Yes.
Yeah, please, Pak Daryono, please. Pak Daryono is the head of
Yes, I asked.
earthquake and mitigation of BMKG.
Okay. Yes, I asked Professor Mauricio Pepe. Sir, I am interested in the elastic beacon that you had present. It is an expensive instrument. It is my question, because there are so many components as part of the system. At least the installation seems not quite easy, that we need a big ship to bring the instrument, the beacon close to the volcano. I think we would consider the cost of the instrument, because when it hit by a pyroclastic flow or pyroclastic cloud or flank collapse, it will be broken and we will lose our investment. It is expensive. Is it expensive instrument, sir?
Okay, so first of all, the elastic beacons, as I show, were inside the pyroclastic flows. There are 300 meters from the coast, so they were completely inside the pyroclastic flows in 2019. So this was the first answer. The second answer is that the mandate of the Italian civil defense was to realize a low cost, probably not as inexpensive like Alessandro device, but low cost. And when I say low cost, I compare to dart buoy or something similar. So it's probably more than 1/10 less than a dart buoy. I cannot exactly give you the total price, but we are around 150,000 euro. Okay? All included. It means installation, instruments, and the devices. So it's comparable with a couple of seismic stations. So it depends when so it's not a dart, first of all. So this is the. I don't know if you want to have the precise price. I don't have it.
Thank you. Yes,
but I can give you the order of magnitude. The order of magnitude is 100,000, around 100,000 euro, 100,000. Okay. For the installation, I will not install it too much close to a very dangerous volcano. Okay? A little bit far away, but we install it very, very close because we want to have the shortest alert time. So that was another mandate of the Italian civil defense. We cannot decide by ourselves where install it. They want us to install it there. And this is what we did. And we were happy that they survived 2 pyroclastic flows.
Yes.
So I don't know. I think the answer is there. It's on the sea. They are still there.
Okay. I like things.
Thank you very much. Is there
Okay,
any more,
once more.
Father?
I asked Dr. Alessandro Annunziato.
Okay, Dr.
Doctor,
Alessandro.
would you please elaborate more about the algorithm of short-term forecast and long-term forecast differences, and then you convert to amplitude? I think it is different approach with the STA LTA ratio that we usually learn. I need more explanation about it.
No, it is not very much different. It is only that we consider, in addition only to the amplitude, we also consider the root mean square of the amplitude, because we want to be sure that in case of noisy signal, you do not have a false alert. So let's say they are very close. If you consider the tided signal, then it becomes very similar to an STA. The STF and LTF becomes very similar to LTA, STA. But in addition to that, we also, as I said, we also compare the signal with other mechanism, that is the root mean square of this amplitude itself, in order to avoid this problem of noisy signals. And that's all.
Okay, thank you.
Thank you very much, Pak Daryono, for
Yes.
the questions, and also Dr. Annunziato and Professor Ipepe for the brief answer and a very accurate answer, very blatant answer. Thank you very much. Maybe we'll just gonna move on to the last session of our discussion today, the closing remarks from Pak Daryono himself. Pak
Okay.
Daryono has already been here. Is
Okay,
there any
thank you.
more? Maybe some addition maybe before we move on to closing remarks. Dr. Annunziato and Pak Lipepe. Sorry, Professor Lipepe. Before we move on to Pak Daryono. How do you guys feel about this discussions? Should we make it more often, or
From
any
from my
suggestions?
side, it was very interesting to learn about the strong improvements in the BMKG system, because this was something that is still there since I would say since the Palu earthquake. It was felt very important to make some improvements in this sense. So I'm very glad that BMKG is improving in this sense. I wonder, let's say, if this can be generalized and can be, let's say, made for every sensor in the world, that should be treated in that way, so that you can realize not only volcano but also landslide, because there are some cases in which you have landslides, and when you do not have the knowledge of where the landslide will occur. So using the same method for all the devices and excluding, of course, the false alert, you can really make a big improvement. So I'm very glad about that. About also the instrumentation, very nice that there were a lot of plans also for installing additional instrumentation from SEMEDI and BRIN. So thank you. It was very interesting for me. Thank you.
Is there any more additions to what Dr. Annunziato has said? Thank you very much to Doctor for being present to our discussion today and giving a very valuable knowledge to our audience. Maybe Professor Pepe can add something more.
Yes, I just want to say thank you for this invitation. It was very interesting. Probably we have many problems in common, it seems, between Stromboli and Anak Krakatau. And I have to say thank you for this interest in what we do in Italy, and hope we can discuss longer on how to solve those common problems in future.
Thank you very much for sharing the confusion to us. Thank you very much for presenting in this forum, and maybe Pak Januar and Pak Sumedi can give some conclusion to our discussion today.
Yes, first, of course, thank you very much to BMKG, Pak Hafiz, Pak Daryono for this opportunity, because we met, I think, last October in Italy with Maurizio, also with Alessandro. So now, finally, we managed, to discuss again together about the same issues, and we could see that we still have lots of homework, especially for the Krakatau, and also we still have 7 other volcanoes underwater in Indonesia, which still not monitored, especially for the tsunami. So it's very clear that I really hope for myself that in the future, we can always work together, how to solve these issues, and also to provide a solution, how to provide robust monitoring for the volcano in the sea, especially for the detection of tsunami. Thank you.
Thank you very much, Pak Sumedi, for the conclusion and for presenting in this forum. And maybe the last one is Pak Januar. Pak Januar, is there anything that you would like to add?
Yeah, we realized that there are many. It's a big challenge for us, for BMKG, and for the system what we have done. But we believe and we realize that there are many things that can be enhanced. And thank you very much for Professor Maurizio, Dr. Alessandro, Pak Sumedi. In the future, hopefully we can learns much learn and in collaboration and cooperation and how to and give a great insight for us how to build, how to construct a great robust yearly warning system, especially for the atypical tsunami. Thank you very much. I think that's all. Thank you.
Thank you very much, Pak Januar. With that, let me conclude our presentation. Thank you very much, and let's give a round of applause to all of our speakers, Professor IPP, Dr. Annunziato, Dr. Smedi, and also Pak Januar. Thank you very much, everyone. And then let's move on to our closing statement, closing remarks from Pak Daryono. Pak Daryono, can you please? Yep, thank you very much, Pak Daryono. I'll give the time to you.
Okay, thank you.
Stage is yours.
Okay. Excellency Professor IPP, Dr. Annunziato, Dr. Sumeti Usren, it is great fun for us with you in this seminar and all webinar participants. Ladies and gentlemen, we are getting to the closing time. I think the webinar has been successfully completed and I congratulate for the discussion well done. At the end of the meeting, I would like to say many thanks for your all kindness and effort to participate in this webinar and getting along with the TAU meeting with the TAU schedule. I'm very happy to know that all of the participants have learned a lot from every single part of the session. On behalf of BMKG, I would like to thank of the organizing committee who had led the discussion in this meeting. My biggest gratitude to all of you here for making this successful webinar through your valuable contribution and active participation throughout the webinar. Ladies and gentlemen, I would like to close my remarks and officially announce the end of webinar, Detection and Warning of Tsunamis Generated by Volcano Activities. Wishing the future of collaboration. Thank you for your attention.
Thank you very much, Pak Daryono, for giving the closing remarks. For everyone who's attending this webinar, I would like to kindly remind you all to fill out the attendance form that has already been put in the chat group so that we can print out the certificates for you guys. Once again, thank you very much for all of the 4 speakers and also Pak Daryono, all of the committee that make this discussion possible. I'd like to also point out that BMKG is planning to have a collaboration with the University of Florence regarding this matter. I'd like to just point out that before ending this session. Thank you very much, everyone. I wish you all a wonderful evening and a wonderful afternoon to both of our experts from Italy. Thank you very much. I hope to see all of you soon. Assalamualaikum warahmatullahi wabarakatuh. Peace and blessings to all of you guys.
Thank you.
Thank you.
Thank you very much,
Professor. Thank you very
See you,
much.
sir.
Thank you,
Thank you.
Dr. Alessandro. Makasih Pak Smedi semuanya.